Hello guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 352 that says data stream as disjoint intervals. So this is the problem of the day, and yeah, I'm sorry for that I'm making a video very late. Usually I make the video of the daily question in the early morning, but since I was traveling today from early like around 4 a.m. so I was not able to make the video. Okay, sorry for the late video. Okay, so whatever it may be the reason, now let's focus on the question and the approach part. So talking about the question is, here we are given one data stream input of a non-negative integers, and we need to complete two functions. One is addNum and second is getIntervals. So this addNum will tell us that this value is to be added to the data stream, and getIntervals is where we need to return the intervals in the form of vector int. So the intervals has two elements only, that is the start and the end of the element. And let's say if you have elements like this, so yeah, if you have data stream like this 1 2 3 5 7 8 10 like this, so the intervals here are 1 2 1 comma 3 5 7 comma 8 and 10. So it is 10 comma 10, here also 5 comma 5. So these are the different intervals that are possible for this data stream. See 1 comma 3, why? Because 1 2 3 are continuous elements. 5, there is no continuous elements from before it and after it, so the interval is 5 comma 5. So these are the different disjoint intervals that we are trying to find out from the data stream. Got it? Now let's take a look at the first example to get better understanding. So initially we have no elements in this array, then we added one element 1. So the current array is this, and the disjoint set is 1 comma 1. Then we added 3 here with this addNum, and we call getIntervals. So the intervals currently are 1 comma 1 and 3 comma 3. Then we added 7. So the intervals are 1 comma 1, 3 comma 3, 7 comma 7. Then we added 2. So here it is when the changes come. So initially it was 1 comma 1, 3 comma 3, because there was a break. 2 was not present, but now we have 2, so we can combine it and form one interval, that is 1 to 3. Okay, and this remains as it is 7 comma 7. Now we added 6. So here 1 2 3 was already there, so now instead of 7 comma 7, now 7 has one element before it, so it forms a continuous interval 6 comma 7. So we modified this to 6 comma 7. So yeah, I hope you guys understood the equation, that every time we add one integer to the stream and we try to generate intervals after adding that integer. And I hope you also understood that how the intervals are formed, means what is the exact meaning of the intervals. Now one thing to keep in mind is total number, the value is 10 is to 4, and at most 3 to 10 is to 4 calls will be there of addNum and getIntervals. So if you let's say if you add all the values, keep on adding the values in one vector, and then try to generate all the intervals at all time, means at all calls, then it will give you TLE. So here what we have to do, we need to let's say we need to pre-compute an answer, and every time when we are adding one new number, we will add that number in the previous intervals by checking some of the condition. So for this type of question, what I suggest you, that see, looking at this question, there is no DP. This is not a DP question. You can see that this is not a graph or tree based question, not a linked list or sorting type of question. I'm trying to tell is there is no definite data structure that can be used here. So for this type of question, what first thing you need to do is you need to generate different types of test cases that are possible. So if when you will try to generate these test cases, you will get more idea of how to solve this question. Okay, so here I have taken a few test cases to explain you the creation more in more depth. Yeah, so starting from the first, so if currently the intervals are 1 comma 3 7 comma 9, and there is one function called to add num of integer 8. So after this, what would be the answer? 1 comma 3 would remain as it is, also 7 comma 9 would remain as it is, because 8 lies in 7 comma 9, right? So we kept answer as it is the original intervals. Okay, now let's take a look at this example. So if you have this as a current interval, and if you try to add a number 4, then what would be our answer? Our answer would be 1 comma 4 and 7 comma 9. So here 4 was just at the boundary. So what we did, if 4 was at the boundary, we just made this equal to 4, right? The end of this interval. Got it? So this is how we did here. So if this is the case, where 6 is just previous of this interval, then what we will do, we will do 6 comma 9, right? Just because it was just before the starting of the element of this interval. Okay, and if you have something like this 1 comma 5, 7 comma 9, and 6 is between 5 and 7, right? Then what our answer would be 1 comma 9. Okay, because see, it would be 1 comma 6, and also 6 is also previous of 7 comma 9, then 6 comma 9, then combining both will gain 7 1 comma 9, right? And if you have, let's say, current interval is like 1 comma 3 and 7 comma 9, and you get add num function call with a value, let's say 11. So if there is an element that is neither a part of this or not a part of this, then what we would do, we would simply make a new interval. So based on this, what you saw that we are either checking, so if element lies in between or some of the intervals, then we are checking with the previous element or to the next element, right? This is the previous element, this is the next element. If it is neither a part of any of the intervals, then we simply add a new interval 11 comma 11. Okay, so if you have, let's say, if you have large data stream like this 1 comma 3, 2 comma 5 comma 9, then 11 comma 17, 20 comma 25, 29 comma 33. So if you have large number of intervals like this based on the data stream of the previous data stream elements, so now you have now there is one function, and num function is called for the element, let's say 10. Okay, now in order to find where in order to check this condition, what we have to do, we have to find that point where 10 will come. So as you can see here, the 10 will come after this ending of this and before starting of this, because after 9 this the ending interval is 9, so after this 10 will come and the starting interval is 11, so before that 10 will is come. This is correct, right? So how we can find this point? So this point can be found by using lower bound. That is what lower bound does, right? So a lower bound is basically, you can say it is a binary search only. Some similar logic of binary search is used here. So if we get a lower bound, then we will get index of this and an interval whose value is less than 10. Got it? So we will get lower bound with value with index this. So if we get this index, then would not it be easy to add this element? So if we get this index, then we would have to check for this element and this element. So if it is the case like this, let's say here, so we are only checking this element here, if this element only, right? And if a element lies between this, then we don't have to worry anything, right? We will simply return from our answer. So what you understood from this intuition, from this test cases, is whenever you try to insert a new element, you check for the where it will lies. Means you check for the lower bound index of that element from the interval side. Got it? So using using this lower bound, we try to add this element by checking this condition. We will simply check all this condition and our answer would be done. That's it. Okay. So yeah, so talking about the approach, we will use lower bound to found the index. When we find the index, we check for all the condition that is discussed here, and generate or make changes as per the condition and return intervals. Got it? This is simple as this. Once you once you understood this logic of lower bound, then why we are using lower bound here? Because we won't be adding 10 anywhere at other place. We would only have add this element at a certain place, and to find this certain place, we need to find the interval whose value is just less than 10, right? So that's why we are using lower bound. So I hope you guys understood the intuition as well as approach for this question. So now let's move on to the coding part. Okay, so now let me make here one vector of vectors, interval. Okay, now let me take one n as a interval. So let me keep this as simple inv for faster typing. Inv dot size. Let me also initialize one infinity variable and initialize to int max. So yeah, Now what we need to do, find the lower bound. Int index is equal to lower bound of intervals dot begin, intervals dot end, and we need to compare something, compare with the value, and minus intervals dot begin. So this is how we will get the index, right? This is a syntax of a lower bound. But one thing to note here is this is vector of vectors, so we can't add directly value here. What we need to do, we need to make one temporary vector. We would push this value into this temporary vector, and we would pass this here. So if it was simple vector intervals, then we would only pass directly value. But here, since this is the case, so we need to pass one vector with and we inserted this value, right? Now once we get the index, we need to check something. Okay, now let me take some variables like pre-start, pre-end, next start, next end. Okay, so what are, you might be wondering that what are this pre-start, pre-end, next start, next end? So yeah, if this is the lower bound, then this is the pre-start, then pre-end, this is next start, this is next end for element 10, right? Now we would check for if index is less than 0. Okay, so that means let's say if our interval starts like this from, let's say, 3, 5, 7, 9, and our number is, let's say, 1. So so there is no intervals before whose elements or whose values are less than 1. So in that case, our index would be less than 0. And in this situation, we would simply make pre-start equal to minus infinity and pre-end equals to minus infinity. Else what we would do, we would make pre-start equals to the value, that is intervals of index of 0, and pre-end intervals of index of 1, correct? One thing to note here is we also need to do intervals -1 because to make it 0 index, right? Now for this next start and next end, if index is greater than n, greater than or equal to n, then in that case what we would do, we would make next start equal to infinity, next end equal to infinity, and in the else case we would make next start equal to intervals of index of 0 and next end equals to intervals of index of 1. Okay, yeah, I think that you got till now. Now what is our next task? Our next task is to check for all these 4 conditions that I discussed before. Now the first condition is, let's say if value is greater than equal to pre-start and value is less than equal to pre-end, or it is greater than equal to next start, or the value is less than equal to next end. That means that the element lies in somewhere. Let's say for 8 lies either in the previous or in the next interval, between the next interval, like 7 to 8, like next start and next end, or either pre-start and pre-end. It lies somewhere. Then what we do, we do not think, we simply return here from here, because we don't need to make any changes. We didn't make any changes here because that's already included, right? Now in the else condition, in the else if part, what we would do, we would code for this situation. Let's say we code for this in, okay, then what we would do, that if pre and equal to value plus 1 and next start equal to value -1. That means for, let's say, add number 6, the pre-end equal to the pre-end plus 1 equals to value and next start -1 equals to value. So here for this condition, if let's say pre-end plus 1 equals to value and next start -1 equals to value, then what we do, this pre-start, we make an interval, we erase this interval and we make interval with a pre-start and next end. So what we do, interval of index -1 of 1 equals to next end, right? And we erase that second interval dot erase what is that, iterator would be inv dot begin and plus idx. Okay, So this is the thing we did here. We erase the second iterator, sorry, we erase the second interval and change here. Now moving ahead, what is our next condition remaining? This condition is remaining where we simply increment our pre-and here. So that is if pre-and plus 1 equal to value. Then in this case, what we do, we would make intervals of index -1 of I equals to value, right? And there is condition if next start -1 equals to value. In that case, we would simply change the next start, that is index of 0, and we would modify its value to value. Got it? And in the else condition, if nothing is there, then what we simply did, we simply added the intervals. Yeah, that's the same thing we are doing here. I and v dot pushback, where we would push at the index position dot, it is begin plus idx comma the value is value comma value, right? Okay, and in here we would simply return I and v. That's all. We have to do nothing here. Everything is done in this addNum function. Now let us try to run this code. Okay, it is the small n. Yeah, that's it. VALUE. Okay, the thing here is we can't make it push back. We need to insert at this index, right? That's the syntax. Okay, one thing you to note here is here it will be less than equal to 0, right? Because we are using -1 here to get the previous index. So if it is also 0, then also we have to make pre-start and pre-end as negative of infinite. So yeah, now our code got accepted. Now let me try to submit this. So yeah, as you can see, our code got accepted. And now talking about the time complexity. The time complexity would be big of n log n because of this lower bound function that we are using, and the space complexity would be big of n for for let's say n number of intervals, you can say there, or you can say for n number of this n number of values. So that is the maximum possible space and time complexity n log n and big of n. So yeah, that's all from my side today. Hope you guys understood the question, the approach, as well as the code part here. And if you have any doubts still, then let me know in the comment section. Make sure to like this video and subscribe to our channel. Thank you.